Okay, the book we're going to talk about, this is a book review, and the name of the book is Explaining Unexplained Illness. The author is Martin Pall, Dr. Martin Pall. He's a PhD, and this is a brilliant book. I put this in my top 30 medical books of all time. Now, this guy is like a Caltech biophysicist guy. He's very intelligent. I think he's a little bit Asperger autism. So it takes a while. He kind of reminds me of Dr. Esselstyn, but Dr. Esselstyn's more dynamic in his personality than this guy is. He's got a personality, emotional range of about this much. But the book is brilliant. It's a work of genius, okay? He started seeing all these diseases that nobody could explain, and he was digging around in the research paper, and he figured out that he could make sense of it all. And there's really no other good explanation for these diseases. So the main diseases he was focusing on originally were these rare diseases: chronic fatigue syndrome, multiple chemical sensitivities, fibromyalgia. But he started realizing that it was appropriate for other more common diseases, things like post-traumatic stress disorder, Gulf War syndrome, tinnitus, and other diseases. And that's where it starts getting really interesting. And then I was also fascinated by this because a major part of what he's talking about is intracellular calcium metabolism. And my own personal theory of neurodegeneration, the Peter Rogers MD theory of neurovascular uncoupling, has a lot to do with calcium signaling intracellular. So I think you're going to find this talk way advanced. I'll try to make everything as clear as possible, but the stuff I'm talking about, none of your doctors will know this. Your neurologist won't know this, none of them. Okay, this is not in any of the medical textbooks. This is way beyond all the medical textbooks. To me, the medical textbooks are kind of a joke, okay? They're just, manuals to help, junior people sell drugs, okay? But we're going to go into some good stuff. Here's a typical thing Paul would say. Putting tens of millions of 5G antennas without a single biological test of safety has got to be one of the stupidest ideas anyone has ever had in the history of the world. Okay, so he says it like it is, all right? All right, now here's the point that I think you want to get through your head. This is an important point to get. Okay, so see these guys with all the straw on the camel's back, the hay? And the point is this. No matter what you do, you've already got at least 50 things that are damaging your health right now. So the smart move is control and stop all the ones that you can to optimize your health. Because I know lots of people, I talk to lots of people about nutrition. Wherever I run into people, I always end up in conversation about health and nutrition and all this stuff. And most people, they really don't get it. A lot of my relatives, including my relatives with their graduate degrees, their physicians and all that stuff, they don't get this. Is that you sometimes hit a threshold point where you tip over the edge and you start going downhill. So you want to just get rid of all the negative stuff as best you can so you don't have the last straw that broke the camel's back. And this will make sense in a moment. For example, when I talk about mitochondrial inhibitors, my mitochondrial inhibitor slide is over 44 causes of mitochondrial inhibition, and about 30 of them are common. So it's very easy to have a bunch of things nickel and diming you and dragging you down. And we'll talk about how to avoid all this stuff as we go along. Okay, so now the first big dilemma here is, Caldwell Esselstyn and Nathan Bryan and Beth Shirley, they're like the three most famous people that promote the benefits of nitric oxide. All three of them will tell you that nitric oxide is like the greatest thing in the world for health, and we must try to increase it, okay? So, oops, I didn't mean to cover up Hegel. Sorry about that. I was looking at the wrong thing on my thing here. I got to make this red here, and then I can move it. All right. So I'll shrink myself here. And basically, this is Soren Kierkegaard, the Danish Socrates, and this is Friedrich Hegel, the German philosopher guy. And normally I love Kierkegaard and I think Hegel's a pain in the ass, but in this case, we'll talk about it. Okay, so here's the dilemma. Then here's Martin Pall, and there's also some pretty prominent naturopath and physicians, Bob Miller and Jill Carnahan. If you go on the internet, you'll see they talk about these things a lot. They're all saying, no, be careful, nitric oxide, it's dangerous, it's bad, we must try to decrease nitric oxide. It's an oversimplification, but that's the gist of it, okay? So why is it that, Martin Pall, the guy's a genius, okay, Esselstyn's another guy who deserves a Nobel Prize, how could they say the exact opposite things about nitric oxide? Okay, is this basically Soren Kierkegaard dilemma? Soren Kierkegaard would say that most dilemmas, forget this nonsense of Hegel, most dilemmas are yes and no. You're either pregnant or you're not. You're either married or you're not. Okay, you're either right or you're wrong. You're either Christian or you're not. Okay, whereas Hegel's like, hold on a sec. Hegel's like, we start out with a thesis, one idea, and then we have an opposite idea or a competing idea, antithesis, antithesis. And then we can look at where the unity is, the common ground, and we can create a synthesis, okay? So even though I think Hegel's kind of a scumbag and I love Kierkegaard, in this case I'm going to go with Hegel. Hegel's way of thinking is better for this question. So I'll explain what that means in just a moment. First of all, nitric oxide is not just one thing. Nitric oxide is actually kind of like Dr. Jekyll and Mr. Hyde. There's more than one type of nitric oxide. So the good nitric oxide is what comes from endothelial cells. And then you've got the one in the middle. I'll just look at the middle spot right here. That would be neuronal nitric oxide. That could go either way. And then inducible nitric oxide has a little bit of good in it, but it's mostly bad. All right, here we go. So here is Dr. Jekyll and Mr. Hyde. And basically, Mr. Hyde was the evil one. Dr. Jekyll was the good one, green, like green for plants. And that's the good NOS. That means nitric oxide synthase. That's the enzyme that makes nitric oxide. E for endothelial nitric oxide. It's also called nitric oxide 3 because it's in different types of cells as well. The way I remember it's number 3 is you got 3 little things on the letter E and you got number 3 with 3 little parts, lines sticking out. N is neuronal nitric oxide synthase, and it's also called NOS1. And you can remember that N is 1 letter, and so is that number 1. I remember iNOS is number 2, and you can remember there's 2 parts of the I, the line and the dot. For what that's worth, that'll sometimes be helpful if you decide you want to study this more. Okay, some general concepts. You're going to hear the word oxidative stress a lot. What is oxidative stress? Okay, oxidative stress is when you've got more oxidants, things that steal electrons. An oxidizer is something that steals an electron, and that's things like F-, lipid peroxidation products. But the big ones we care about are superoxide, O2-, hydroxyl radicals, and nitric oxide is sort of the good free radical, but peroxynitride is the bad one. You're going to see ONOO a lot. People actually often call this cycle the no cycle. No, oh no, okay? And there's a good reason for that. Your antioxidants, they come from plants. They donate electrons. Typically, there'll be a big molecule, a bunch of double bonds to stabilize itself after it's donated electrons so it doesn't become hyperreactive. And you get these plants because plants have to be able to protect themselves with chemicals. Okay, we showed this picture once before in a previous lecture. So what's this all about is your plant has to stay out in the sun when it's hot, 100 degrees outside. You can walk into the shade. So 5 minutes later, you're in the shade all happy, but the plant's still out in the hot 100-degree sun, so it has to protect itself with antioxidant chemicals. You don't get them from eating animals because the animals already used them up. Okay, here's just a brief, quick summary of my theory. You've probably heard it before, Peter Rogers' theory of dementia, of neurovascular uncoupling. You basically got a baseline metabolic rate, and you got a baseline oxygen and glucose delivery. And so here is I use GOD, God, as a glucose oxygen delivery. You could have made it OGD, but I made it GOD for fun. MR is a metabolic rate. So things that are going to decrease oxygen and glucose delivery. You eat a high-fat diet, you eat a lot of sodium, you vasoconstrict, and all these other things that cause atherosclerosis, for example. And so if you drop the oxygen and glucose delivery relative to the metabolic rate, what ends up happening is this neuron's at risk to die. And then if you simultaneously ramp up the metabolic rate by caffeine, MSG, psychological stress, manufactured free glutamate like MSG, like glutamate, they're excitotoxins. They increase the metabolic rate. Sleep deprivation, corticosteroid medications, smoking tobacco, amphetamines, attention deficit meds, glyphosate, all of those things, and the BAP oligomer, which is the beta amyloid protein associated with Alzheimer's. Then the wider this gap gets, these neurons might just die because their metabolic rate is too high relative to glucose and oxygen delivery. So that's severe uncoupling. Uncoupling means you got a neuron and you got a vascular system, and they're normally coupled. If the neuron becomes more active, the vascular system will dilate to supply more blood to it. Okay, that's what should normally happen. But if you start widening this gap more and more, eventually that neuron will just die. It goes into programmed cell death, into a form of what has been called apoptosis, okay, gradual cell death. All right, so now we're going to talk a little bit about what is this all about. So here's NO for nitric oxide. And these are the things that all make nitric oxide. eNOS, endothelial nitric oxide for endothelial cells. nNOS from the neuronal nitric oxide producers. I for inducible. So they're really quite different, okay? And this is how I started out making this slide, and these are things that inhibit nitric oxide synthesis. By the way, eNOS and nNOS are sometimes called CNOS, meaning constitutive, in the sense that they're only made when cytoplasm calcium goes high. whereas the reason for making high iNOS, inducible nitric oxide, is different. Another thing we're going to need to know about is uncouplers. The most important one to know is a lack of BH4, which is, think of that as being like tetrahydrobiopterin. You need that in order to have nitric oxide synthase function correctly and make nitric oxide. If you're lacking in BH4, for example, it could be oxidized by peroxynitrite. You'll then end up having what is called uncoupling of the nitric oxide synthase, and you'll make superoxide anions. These are superoxide anions. So it's like oxygen, but with an extra electron unpaired in the outer orbital, such that it has a negative charge and it's highly reactive. You don't want this to happen. All right, this is bad. And that's the main thing that does it. There's a few other things that can do it, but for our purposes, that's what you need to know. A lack of BH4, especially in the presence of peroxynitrite, leads you to uncouple nitric oxide synthase and start making more superoxide anions. That's bad, because when you've got a lot of nitric oxide and a lot of superoxide anions, these combine together, the nitric oxide plus the superoxide anion, to make peroxynitrite, and you don't want that. Okay? And pretty much all the bad habits you know, cigarette smoking, being lazy, don't exercise, high-fat diet, being fat, having diabetes, excessive dietary salt, they all make it worse, as you would expect. All right, so now I'm going to show you, I started out with that slide, and then I had to refine it as I went along because there's so much more to it. And so the conclusion I came to is like, how can I explain this to you and keep it reasonable? And basically, you have to look at nitric oxide as two categories. This is the Dr. Jekyll, the good guy, so to speak, of nitric oxide. What is produced by the endothelial cell is almost always good. What is produced by the neuronal NOS is good most of the time. It's very important, actually, for our whole learning process, learning and memory. Okay, and the key point about these is that they are constitutive, meaning that they're only increased when they're needed. And they make nitric oxide in very small amounts. NM is for nanomolar, tiny, tiny little amounts. And they're usually on only for a few seconds or at most a few minutes. Okay? So this is just, what you need is made when you need it, and then it goes away. That's the perfect way for nitric oxide to function. All right? With inducible nitric oxide, the situation is very different. This is especially made by immune system cells, although it is made by many other types of cells. And inducible nitric oxide, when it's being used to kill a bacteria, that's good. But it's often being used in situations where you really don't want it elevated. And this produces much higher quantities, much, much, much higher, thousands of times higher. This is in micromolar concentrations, okay? And it's often turned on for hours at a time. So you can make tons and tons of nitric oxide here, far more than when you would ever want. And you can see what a disaster of a situation you have if you've got uncoupled nitric oxide synthase producing superoxide anions, or superoxide anions being produced for other reasons, like let's say in the mitochondria because you're eating a high-fat diet, simultaneously with an overload of nitric oxide made by iNOS. That's a disaster, because then the superoxide anion combines with the nitric oxide and you produce ONO. This is peroxynitrite is what it's called. And this goes around causing tons of trouble. Think about it as like bouncing a super ball in a glassware shop, okay? Bull in a china shop. It's a disaster. You don't want that. Okay, now what activates it? The way you can remember what activates iNOS is pretty much anything that starts with the letter I. Ischemia, lack of oxygen, okay? Injury from trauma to the brain, traumatic brain injury. Infections, okay? LPS is the gram-negative endotoxin. LTA, lipoteichoic acid, is the gram-positive bacteria endotoxin, okay? Inflammatory cytokines, and that can be things like tumor necrosis factor alpha, interleukin-1, interleukin-6. Inter means between, leukin means white blood cells, so communicating cytokines between white blood cells, interleukin-1 and interleukin-2. And those will activate nuclear factor kappa B. And what that does is it's a transcription factor that goes to the nucleus and says, make more of this inducible nitric oxide synthase. The other thing that's different about iNOS, inducible nitric oxide synthase, compared to these guys over here, the constitutive versions of the enzyme, is that this one is not dependent on high intracellular calcium, high cytoplasm calcium concentrations. So once it's on, it can stay on a long time in huge, thousands higher than you want it, quantities, and do a lot of damage. Okay, what else do you want to know about? There's other enzymes in the cell. So most of your nitric oxide typically going to come from your mitochondria. But this other enzyme NADPH oxidase, that can take electrons from NADPH and use them to make superoxide anions. And that can be stimulated by LPS from bacteria, by EMF, cell phones, Wi-Fi and all that, by mold toxins, by sulfites. So the point being is when that's in high amounts, that's going to use up a lot of your NADPH. The relevance being NADPH is also a cofactor for making nitric oxide. So if you don't have that available, you're not going to be able to make the good nitric oxide. We don't need to get into all those details, but I just want you to know this is used largely by your immune system to make superoxide anions. Xanthine oxidase can also make a lot of superoxide anions, all right? Mitochondrial dysfunction is the main context we think about for producing superoxide anions, like high-fat inhibiting complex 3, for example, especially saturated fat. Other things that will activate iNOS will be if you're intoxicated from alcohol. If you've got insulin resistance, you'll have more advanced glycation end products. You'll have hyperglycemia, high blood glucose. That can also lead to activation of iNOS. So just be aware of that. We'll start getting into what that really means here in just a sec. So here's another picture of Martin Pall. And, the main focus is not all the EMF and the cell phone stuff, but he's also a world-famous expert on that subject as well. He kind of looks a lot like Dr. Esselstyn, too, doesn't he? All right, so anyways, humans are electrical. Their brain, you can follow the brain waves with an EEG, electroencephalogram. You can follow the heart with an electrocardiogram. They use the K instead of the C because that way it sounds different than the E and the G. Okay, peripheral nerves and muscles, you can check them with nerve conduction studies. Every individual cell has a plasma membrane gradient. All your neurons will typically have a plasma membrane gradient in the ballpark of negative 65 millivolts. Neurons use typically 2/3 of their energy to maintain their plasma membrane potassium sodium ion pumps. The point of this slide is electrical, because we're going to get into stuff that's disrupting the electrical system of the human body. So you need to know that. And much of the remainder of the energy of a neuron, so after using 2/3 on its membrane ion pump, it's using another huge percentage for its plasma membrane calcium ATPase and its sarcoplasm endoplasmic reticulum calcium ATPase. The bottom line is tons and tons of electrical energy. It's the main thing a neuron spends energy on is maintaining its ion pumps. Okay, and the neurons, what do? They convert an electrical message of an action potential into a chemical message of a neurotransmitter and back and forth. That happens all day long, billions of times. All right, now cell phones. I've talked about this more in other lectures. We're not going to talk about them much, but basically I think they're stupid. And, typical genius here holding up the cell phone to his head. So he's opening up his voltage-gated calcium channels, opening up his blood-brain barrier while he's simultaneously smoking a cigarette, inhaling the toxins in there, including excitotoxins. Here's a wonderful phone that has a cigarette lighter on it. Brilliant, okay? And we've all seen how a lot of people are always looking at their phones instead of paying attention to the people that are around them. And this stuff, the cell phone industry is sort of like the new version of tobacco, and they spend tons of money. They got billions and billions of dollars, so they got the best lawyers in the world. And you know that, for example, the insurance companies, the health insurance companies, they refuse to insure these wireless industries. So the wireless industries are going to take their money and lobby to get the laws changed to protect them. But the point I'm saying is there's tons and tons of data showing problems with all this wireless stuff, EMF, electromagnetic fields, and whatever context you want to call it. And, these insurance companies will not underwrite the phone manufacturers, the wireless industries, because they know it's not safe. And, Hamlet had a good quote about the wireless industry. One may smile and be a villain. So, yeah, they act like, so-and-so Wi-Fi pioneer or cell phone pioneer or some type of hero. No, these scumbags, they're trying to make an electronic you-know-what type of camp, okay? They're not your friend. Okay, DNA also is a fractal antenna. So a fractal is something that has self-symmetry and repeats itself. And what they found is that structures like this tend to conduct electricity and tend to conduct electromagnetic fields. And unfortunately, what this means is the DNA within your cells gets higher exposure to the electromagnetic fields related to all your electronic appliances, your microwaves, your cell phones, your Wi-Fi routers, and even when you go under power lines than you would like. And that's partly why the DNA can be damaged. And that's partly why these things increase the risk of cancer. Okay. This guy Martin Blank wrote a really good book about cell phones. Okay, a little bit how a basic cell functions. You've got the potassium, sodium ATPase, and you use tons of ATP here, which is the energy currency of a cell. It's like a $20 bill. And it's especially pumping out sodium, and that establishes a negative resting membrane potential for the cell, for any cell, especially for neurons, but for any cell. And then this electrochemical gradient, it's electric because there's a charge differential across the membrane. It's chemical because there's a sodium concentration difference across the membrane, and that's used to pump out calcium. So it's coupled. This is primary active transport using ATP. This is called secondary active transport, meaning that it uses the gradient that was established by the primary pump. You're always going to have to use ATP to pump against a gradient in some form or another. For example, calcium has 15,000 times higher concentration outside the cell than inside the cell. So you're going to have to use ATP to pump against it, okay? And so that's called the NACA exchanger. Na for natrium, sodium in Latin, Ca for calcium. All right, and then what else? Calcium tends to be the big deal in a cell. When you get high intracellular cytoplasm concentration of calcium, that's when the cell does whatever it does. If you're a neuron, you'll release your neuron transmitter. If you're a vascular smooth muscle cell, that's when you contract your muscle, okay? That's how a cell gets its work done. Now, just showing you a little bit more fancy detail here. If you're in a pineal gland, when calcium goes up in the cytoplasm, you will then make melatonin. If you're a mast cell, that's when you're going to release your histamine. If you're a pancreas, that's when you're going to release your insulin. Cardiac muscle also contracts, skeletal muscle contracts. If you're a platelet, that's when you become activated, ready to clot. So anyways, calcium is the big thing. Like they said from the movie Lord of the Rings, one ring to rule them all. As far as ions go, calcium is the ion that rules the cell. It tells the cell what to do. Okay, then the cell has to very quickly lower its calcium concentration because it doesn't want to stay activated. So what it does is it'll pump calcium into the endoplasmic reticulum. It's called the circuit just because in a muscle, the endoplasmic reticulum is called the sarcoplasm, but that's what circuit means. Sarcoplasm, endoplasmic reticulum, calcium, ATPase, because it uses an ATP because it needs energy to pump into this concentrated storehouse, which is the endoplasmic reticulum, where you store calcium inside a cell. Okay, then you have something called the PMCA, plasma membrane calcium ATPase. That also requires ATP because you're pumping against the gradient of the high concentration of calcium outside the cell. These things are relevant because you're going to see that they're going to become inhibited by another process. We'll talk about that in just a moment. This is how a cell does its business. Okay, briefly, we got to just mention a mitochondria. Mitochondria has a double membrane. There is the outer membrane, there's the inner mitochondrial membrane, and then there's a space in between those outer and inner membranes. This is called the intramembranous space, and that's where the protons are going to be pumped. Here's the mitochondrial matrix where Krebs cycle runs. Electron transport goes along this inner mitochondrial membrane. Okay, so here's the inner mitochondrial membrane, IMM for inner mitochondrial membrane. This is where all the energy of a cell is produced. Not all of it, but the vast majority of it, okay, over 80% of it. And you're going to pass electrons down this gradient like a fireman bucket brigade, and then eventually you're going to give the last electron to oxygen. It's the ultimate electron acceptor. I'll bring myself back into the picture here. Ultimate electron acceptor is oxygen. It gets converted into water. The energy of the gradient is then harvested by allowing a proton to come back through, H plus is a proton, to come back through ATP synthase. And this phosphate is added to the ADP to become ATP. And that's how most energy is made in the human body. And this gradient's incredibly high. It's like negative 160 millivolts. It's the highest gradient in the human body that I'm aware of. Okay, and the reason I showed you this is just to show you all these mitochondrial inhibitors, okay? There's over 44 of them in just this picture. And you look at them, many of them are very common. F- is in most people's tap water. Most people eat omega-6 oils. It gets made into hydroxynonenal, a toxic aldehyde. Little bits of lead contamination are relatively common in a lot of things, okay? Dumb shit young people sit by their cars talking while the engine's on, inhaling carbon monoxide like dummies. Okay, atrazine is a very common thing sprayed on all these golf courses, sprayed on corn, non-organic corn. It's a very powerful endocrine disrupting chemical, turns male frog into female frogs. Okay, so it's on high fructose corn syrup, which is used in a lot of food. A lot of people take Tylenol, acetaminophen. That's another mitochondrial inhibitor. Cadmium is a common contaminant in non-organic food. A lot of people take statin medications. They interfere with coenzyme Q function. Glyphosate, super common herbicide used on your soy products and many other non-organic foods. Okay, antifungals, the preservatives in tons of foods, anti-mitochondrial. Titanium dioxide, very common. That's harmful as well. When it's a nanoparticle, it inhibits mitochondrial function. PCBs, common in fish and other things. Metformin will inhibit complex 1. Hg is toxic to mitochondria. Trichloroethylene with dry cleaning liquid paper, degreasers. And so these are relatively common things. BPA, PFOAs on nonstick cookware. There's even some people who think that almonds and flax have a little bit of a negative effect. I'm not going to get into all that right now. Manganese from welding, if there's excessive amounts of exposure to that. Some antibiotics like the fluoroquinolones, beta-lactams. So anyways, excessive iron when it's present can be toxic to mitochondria. And you got things that are toxic to other components of the mitochondria besides the electron transport chain, like alcohol, arsenic, traumatic brain injury, multiple food dyes. So what I'm trying to say, this is what I meant by the last straw that broke the camel's back. A lot of the stuff, you're exposed to it. So you want to minimize it all as much as you can, but don't go being half-assed. I think that's stupid in terms of saying, well, I'm just going to eat, fish and chicken on the weekends. You can do what you want, but I think that's stupid because why push your luck with this stuff? Okay, here's how a normal neuron works. It's cell body up here with the nucleus of DNA. It will fire an axon potential, typically beginning right around here, called the axon hillock. And the initial axon potential electric message impulse is transmitted by sodium channels. But once you get to the synaptic terminal distally here, you'll open up voltage-gated calcium channels. And when they open up, they let calcium into the cytoplasm. That raises cytoplasm calcium, and that permits the neurotransmitters to then diffuse from the synaptic terminal to the synaptic presynaptic neurons plasma membrane. And then the neurotransmitter this vesicle will merge with this membrane, and the neurotransmitter will diffuse across the cleft, and it'll exert an effect on the postsynaptic neuron. Okay, and so that's neurotransmission in the brain. And we're going to come back to those voltage-gated calcium channels in a big way. Here's another neuron, just showing you a little more detail. You've got something on here called glutamate receptors. This one's called the AMPA receptor. It's a sodium channel. Lets sodium in to depolarize this nerve. And then once it's depolarized adequately, the magnesium will pop out of the NMDA receptor, also for glutamate. And this low is a calcium channel, which allows calcium to come into the cytoplasm. So you get elevated cytoplasm calcium in the neuron. We show glycine also binding to it, and that's why glyphosate can actually substitute for glycine on here and cause increased activation of NMDA receptors. If you don't eat enough magnesium, which most people don't because they don't eat enough plant foods, magnesium is in the center of chlorophyll, then you can become magnesium deficient. Most common deficiencies are being potassium deficient, magnesium deficient, and fiber deficient because people don't eat plant foods, okay? But if you are magnesium deficient, this will be hyperexcitable, more sensitive, this NMDA receptor. If you eat a lot of glyphosate, this will get activated more often. If you eat a lot of MSG, monosodium glutamate, that can function as an excitotoxin and excite these glutamate receptors. Not good. Okay, when you get the high cytoplasm calcium, you activate the cell to do all kinds of things. All right, now here's basically what happens when you got transmission with glutamate. Glutamate diffuses across the synaptic cleft, binds the AMPA receptor, lets in sodium. That depolarizes the cell, so it becomes positively charged instead of negatively charged. Magnesium, which was attracted previously to the negative 65 millivolt resting plasma membrane gradient, says, screw this, I'm not attracted to a positive charge, and so it pops out. Now it's opened up, and calcium can come through the NMDA receptor. Those are the two main receptors you need to know about for glutamate, the NMDA receptor and the AMPA receptor. There are other ones, but those are the big ones that matter for our purposes. Okay, and then this will cause increased activation of the postsynaptic neuron. It'll elevate the cytoplasm calcium in the postsynaptic neuron, and things will happen. And if you have a normal, small amount of elevation in the cytoplasm calcium levels of the postsynaptic neuron, you'll get a physiologic beneficial effect. But if you dramatically overactivate this NMDA receptor and get too much calcium coming into the cell, you can then start to have harmful effects. And that's a big thing. We're going to talk about that a lot more. So this is sort of the old saying back in the old days, all roads lead to Rome, and that can be in many different ways, artistically, musically, physically, spiritually, okay? But in cellular physiology, all roads lead to calcium. So there's a lot of things that lead to increased calcium in the cytoplasm of the cell. Excessive dietary sodium, ischemia, SERCA inhibitors, mitochondrial inhibitors, traumatic brain injury, all this EMF stuff, cell phone Wi-Fi, okay, excessive stress, lack of sleep. Lack of sleep and caffeine are stress equivalents, okay? Your excitotoxins, okay? Things that are opening up the NMDA channel, for example. There's other more complex physiology that can cause it to open up, but the bottom line is lots of things open up that calcium. This is what I meant by there's many things converging on causing elevated cytoplasm calcium in your neurons and in other cells of the body, and you don't want that. All right, now I'm going to show the same thing in more detail. So basically, stuff that we know about. We talked a lot about excitotoxins, the caffeine, the MSG, the aspartame, another common sweetener. Some psychiatric drugs will lead to this effect of more NMDA activation. Not good, okay? PTSD has a lot of this, okay? Beta amyloid protein in Alzheimer's physiology will also increase this. Lack of magnesium will increase NMDA activity. You can even get it from GABA inhibitors, okay? So GABA is the thing that turns things off in the brain, but if you inhibit that, like with flumazenil used to reverse benzodiazepines, that'll open it up. And there's a few other things that'll do it, okay? Organochlorines. All right, EMF opens up voltage-gated calcium channels. See, there's several different paths to elevating calcium in the cytoplasm, all right? If the cell's hypoxic, lacks oxygen, then the mitochondria doesn't have oxygen to make ATP. That'll lead to a drop-off in the activity of the potassium sodium ATPase, and then you can't run your knockout exchanger. You get higher cytoplasm calcium. There's also something called a TRPV1 vanilloid receptor, calcium channel, and that's activated by volatile organic solvents, so things that smell bad. And all kinds of weird things will come up. This could be from your shirt, and your shirt, if you've got those no iron shirts, they'll have formaldehyde. I threw mine in the garbage. I don't want those no iron shirts because I don't want to be exposed to formaldehyde, okay? And benzene will do it, another organic solvent like carbon tetrachloride will do it, capsaicin. So it's kind of interesting. And this is especially associated with those diseases like chronic fatigue syndrome, sick building syndrome, multiple chemical sensitivities. They're all related to overactivation of the TRPV1 vanilloid receptor. That is a calcium channel. Okay, if you're inhibiting your acetylcholinesterase through organophosphates, well, that's kind of a rare exposure, but just so you know, another way you can end up with higher cytoplasm calcium. Your mitochondrial inhibitors mess this up just because when the mitochondria inhibit, you'll very often be producing a lot of superoxide anions. That's going to become relevant in a moment. Okay, I'll just briefly mention there are some ways you can fight against it, you know, and again, we're talking, it's one thing to have neuronal nitric oxide synthase activated, but the good guys that make nitric oxide, the ones that make it for your endothelium, that's stuff like eating the greens, all that Caldwell-Esselstyn stuff. So Esselstyn was right. It is good to increase nitric oxide in your endothelial cells from iNOS, NOS type 3. It's good to get increased nitric oxide made from sunshine. You've got sunshine precursors of nitric oxide that are activated and released into your blood when you're exposed to nitric oxide. Nitric oxide can actually bind to your red blood cells. That's a long story. We won't get into all that. But anyway, sunshine-related nitric oxide and dietary nitrates, that's a good way to make nitric oxide for your endothelial cells. But iNOS, producing tons of it, that's the bad way. All right? And again, calcium calmodulin enzyme is activated when you have high cytoplasm calcium, and that's needed by eNOS and nNOS, endothelial nitric oxide synthase and neuronal nitric oxide synthase. Okay, but the problem is when you're kind of got half and half, you got this partly uncoupled, or you got mitochondria inhibited and you make a lot of superoxide anions simultaneously with having high nitric oxide levels, then it becomes bad. And then you start forming this peroxynitrite. And peroxynitrite does a lot of bad stuff. It'll block oxidation, it'll oxidize BH4, which will uncouple nitric oxide synthase. So it'll make, here's uncoupled nitric oxide synthase, it'll make superoxide anions, predisposing you to make more of the bad stuff, peroxynitrite. Mitochondrial dysfunction is caused by peroxynitrite, and mitochondrial function leads to it, so that can lead to a vicious cycle. So a vicious cycle is something that feeds back on itself, and it will not get better on its own unless you break the cycle. And it's associated with pain, it's associated with like fibromyalgia, fatigue, like chronic fatigue syndrome, cell death, like some neurodegenerative disorders like amyotrophic lateral sclerosis, for example, ONO, peroxynitrite, will also open up the blood-brain barrier. It's bad in multiple ways. It's all bad. Okay, just briefly, a couple things. Traumatic brain injury opens up the blood-brain barrier. That's all bad. Leaky gut will often be associated with opened up blood-brain barrier. Having a stroke will open up blood-brain barrier. All these things allow more toxins to get into your brain tissue, your brain parenchyma. And those are weird things. A lot of bad diseases, they're associated with what you would call a vicious cycle, a self-perpetuating cycle that feeds back on itself to amplify itself, to increase itself. And if I had to take a theme song for vicious cycles, it would be Ring of Fire by Johnny Cash. Okay, high-fat diet inhibits mitochondria, and that leads to a vicious cycle. You're always putting more toxic material into your body, causing mitochondrial inhibition. You keep the cycle going. The high sodium, low potassium, low magnesium diet of the high meat diet and the oils in the processed food, this is another example of you keep on pumping a negative thing in there to keep the vicious cycle going. Excitotoxins, we've talked about that in previous lectures and a little bit in this one. They're all increasing the activity of that postsynaptic neuron to overwhelm its metabolic rate relative to its oxygen and glucose delivery. Mitochondrial inhibitors and circuit inhibitors have essentially the same effect as excitotoxins. Toxins in your water, things like F-, etc. You're drinking that every day. You're constantly exposing yourself to toxins. Air pollutions like the TRAILS, those will also be toxic to you. Okay, personal care products, they're going to have these estrogenic preservatives. They're going to have this metal in them. All that stuff is toxic. So if you keep on exposing yourself every day to toxic food, toxic air, toxic water, you keep on perpetuating problems for your body to deal with those contaminants. And if you put the last straw on the camel's back by keep adding to this, you can eventually cause some irreversible damage and certainly some significant damage that is harder for the body to repair. Iron overload with ferrous redox cycling. I talked about that in my leaky gut lectures and my Alzheimer's lectures with Douglas Kell and Etheresia praetoris' research with the dormant bacteria and all that. The no-oh-no cycle, we're kind of talking about that now. And EMF contributes to it. Another weird thing about nitric oxide is when you activate NMDA receptor on the postsynaptic neuron and you produce more nitric oxide, some of it will actually leak out of the postsynaptic neuron and leak back to the presynaptic neuron and actually stimulate the release of more glutamate. So that's why you don't want to produce in excessive amounts, because it can perpetuate a vicious cycle. The ONO then inhibits the plasma membrane calcium ATPase and the SERCA, and this will perpetuate high cytoplasm calcium, which can also maintain that vicious cycle until the cell dies. Peroxynitrite does other bad things. It also inhibits mitochondria. It inhibits mitochondrial enzyme superoxide dismutase, making it less able to clear the superoxide anions. Thus, the nitric oxides available will continue to combine with them to make peroxynitrite. So you see, it's almost like it's can't be killed, the peroxynitrite. Once it gets going, it keeps these vicious cycle going, and that's why, in the words of Martin Pall, that's why these are chronic diseases: multiple chemical sensitivities, PTSD, and chronic fatigue syndrome and whatnot. So we're going to talk about ways you can break these negative cycles towards the end of this lecture. Okay. Excessive NMDA receptor activation can activate xanthine oxidase, lead to more superoxide anion. Okay, this just shows the same thing again, whereby you got the nitric oxide. Once it's made, it diffuses back into the presynaptic neuron and perpetuates more glutamate release there. Okay, just a couple papers just showing you the kind of stuff I've been talking about here. Here's effective reactive oxygen species. Peroxynitrite inhibits PMCA, plasma membrane calcium ATPase, leads to more calcium in the cytoplasm. Vicious cycle. Okay. Peroxynitrite inhibits SERCA, so you're going to get more calcium in the cytoplasm. A vicious cycle. So a lot of your really bad diseases, they got some type of vicious cycle, something perpetuating, because the body always wants to heal. You just have to let it heal, give it a chance to heal. And here's what I meant earlier about peroxynitrite. It's almost like, a monster, artificial intelligence gone rogue. Okay, it just does what it can to keep itself elevated. Takes out the mitochondria, takes out SERCA, takes out plasma membrane calcium ATPase. So now you can't clear your calcium from your cell. You can't run your ATP-dependent pumps, and calcium goes through the roof, and eventually the cell just runs itself into the ground. Its metabolic rate's up, and its productivity of energy is down. It'll just die, go into apoptosis. If it stays alive, it'll keep the person sick. Okay, here's a couple of things. We're talking alcohol will activate iNOS, inducible nitric oxide synthase, to make way too much nitric oxide and run these vicious cycles. Okay, here's just showing another example how it elevates iNOS. So you don't want to drink any alcohol. Alcohol is toxic and stupid. Okay, there's nothing good about it. All that stuff previously about 1 or 2 drinks a day was bogus. It's bad. Wi-Fi opens up voltage-gated calcium channels so it can accentuate this cycle. It's also toxic to your gonads besides being toxic to your brain. All this EMF stuff's bad for you. Okay, but the key point, like I said, to reconcile, how could Esselstyn et al. Be correct and Nathan Bryan, and how could Martin Pall be correct? Because iNOS is a good guy, right here. iNOS is a good guy, endothelial nitric oxide. Neuronal nitric oxide is a good guy most of the time to help you with learning, but it sometimes can be overdone and cause problems. iNOS is the one that, yeah, you need it when you're killing a bacteria, but it can easily be overactivated. It's the one most prone to bad behavior and being overactivated. If anybody wants to read these papers, I selected excerpts from like some of the best papers on what's happening. They just in detail explain the vicious cycles that we're talking about. And these are papers not written by Martin Pall. This is not like as Martin Pall's came up with these cycles. All of these cycles are well established in cellular physiology, pathophysiology. What Martin Pall did that was a work of genius was he just read them all and figured out they all fit together to explain chronic fatigue syndrome, multiple chemical sensitivities, some components of tinnitus, some components of PTSD. So that was his work of genius. And by the way, a lot of work of genius just comes from extensive studying. Watson and Crick figured out the structure of DNA just from studying the research that had already been done. Aristotle was perhaps the greatest genius who ever lived. He just classified what was known at that time in the world. Okay, Isaac Newton, when he went back to his cottage in 1665, Anno Mirabilis, the miracle year, he just studied on his own and figured out a lot of stuff. So what I'm trying to say is, you can figure out great things. I figured out, the second best theory of neuronal degeneration just on my own, best theory of spinal degeneration. You don't need, for most stuff, these billion-dollar university projects. Those are usually funded to just try to, come up with a more profitable drug. Don't get me wrong. If you want to look at that faraway planets, you need a good telescope. But I'm just saying, nobody gave McDougall millions and billions of dollars to figure out all the stuff he learned about nutrition, okay? One smart person devoted to studying can learn tremendously useful things. Okay, that's where most good information comes from. Okay, iNOS uncoupling, vicious cycles. Peroxynitrite will also drop production of BH4, and when that happens, nitric oxide synthase, all of them would be uncoupled, and they'll start making superoxide anions, what you don't want them to do, instead of what you want them to do, make nitric oxide in the right context. Okay, especially for iNOS. Okay, here's some more stuff about the pathways. Nitric oxide synthase, some variables. It needs NADPH, so if you use that up with NOx, NADPH oxidase making superoxide anions, this will be in short supply. That's bad. BH4, if it's oxidized by peroxynitrite, that'll be in short supply and cause uncoupling. Okay, so this is just a little bit of a detailed explanation for whoever wants it. You'll see that these pathways are solid. Okay, and you'll get what I'm talking about. Here's a little bit in diagrammatic form. So when you increase iNOS, you make too much nitric oxide, excessive amounts, and that's sooner or later going to run into superoxide anions, and then you're going to have excessive peroxynitrite, and it goes around destroying everything. This just are things that start with the letter I, which will end up inducing more iNOS. Okay, this is just showing BPA. The plastic, not only is it a mitochondrial inhibitor, it also is an uncoupler of iNOS, of nitric oxide synthase, so it'll cause more superoxide anions. It's bad. The BPA equivalents are no significant improvement. Okay, so what are the things you can do to make things better? You got to break the cycle, like the Tasha Cobbs song. You got to break the chain. It's a great song, by the way, one of the greatest all-time gospel songs is Break the Chain, sung by Tasha Cobbs. If you look that up, you'll love it. Okay, so anyways, low-fat, low-sodium diet. With the low-fat diet, you stop inhibiting your mitochondria. You get better flow to the tissues, more ability to heal, more glucose and oxygen delivery. With a low-sodium diet, you stop vasoconstricting the tissues. You'll get more oxygen and glucose delivery, better chance for that neuron to make the energy it needs to heal. You eat your greens, you get more nitric oxide of the good type that works in conjunction with endothelial nitric oxide to vasodilate. That's what you want. That's good. Potassium, vasodilator from plants. That's good. Magnesium, also a vasodilator, and it's needed to run your ATP pumps. That's good. You get that from plants. Magnesium's in the center of chlorophyll. That's what it normally does and is. Eat your starches. You get the fiber. The fiber in your starches helps to maintain not only the gut wall, but it helps maintain the blood-brain barrier. It enables the endothelial cells of the blood-brain barrier to produce their tight junctions. It protects you from getting toxic chemicals into your brain parenchyma. Your fruits will have vitamin C and other antioxidants, and those are also helpful to prevent you from being tipped over in oxidative stress because you'll have enough antioxidants to neutralize the oxidants that are produced. Folate comes from foliage, from plant foods, and that also helps to prevent nitric oxide synthase uncoupling because it's needed as part of the process to make your BH4, your tetrahydrobiopterin. Okay, vitamin B12 is also related to that process in the methyl cycle and whatnot. Exercise also helps you to maintain healthy amounts of your enzymes, the good ones where you need them. Getting your sleep, your stress management. Your stress management comes from having clear-cut goals, knowing what your purpose is in life, your sense of purpose. Having a religion adds meaning to your life and perspective and gives you a better set of metaphysics with which to face the world. Your social relationship with your family, your friends, your social support system. Your sense of the good and the beautiful, appreciation of art and literature and other things like that. They sort of make you happy and they sort of remind you that, yes, there's a lot of problems in the world. Yeah, there's a lot of bad things in the world, but there's a lot of good things too. We do enjoy nature, being out in a pretty nature scene. It can even just be the garden in your backyard, for example. Okay, that's healthy for us. Getting sunshine increases the healthy systemic nitric oxide, the good stuff, the vasodilator stuff. Avoiding all these toxins. They all make you sick and they all run the risk of helping to contribute to and perpetuate these vicious cycles that get running with these diseases. Okay, we talked about fiber protecting the blood-brain barrier. Here's another article on blood-brain barrier being protected by short-chain fatty acids. So basically the fiber in your gut is taken by the good bacteria from eating a plant-based diet, made into these short-chain fatty acids, acetate 2 carbons, propionate 3 carbons, butyrate 4 carbons, and those are used to make the tight junctions to maintain your blood-brain barrier. There's no fiber in meat. There's no fiber in oil and sugar. I got these slides from Gurmeet Singh Manku. He's a nutrition expert who especially studies nutrition in India. Okay, here's the Esselstyn diet. Dr. Esselstyn, we talked about that, how he just goes on and on about how wonderful nitric oxide is, and it is wonderful in your arterial system. So it is good to have it in that sense. From eating the greens, you eat the greens. The back of the tongue bacteria convert the nitrates, NO3, into nitrites. This should be nitrite, NO2s. And then the stomach acid helps convert it into nitric oxide, and that goes into your blood, systemic vasodilation effect. We get that also from sunshine. That's why we feel good when we walk out in the sun. Sun does other good things. So you want to get sunshine. You don't want to just be taking vitamin D by mouth. Okay, what else can you do? You can shield yourself from the EMF stuff. Go from wireless to wired wherever possible. Shield wherever possible. Avoid it whenever possible. Increase your distance from it whenever possible. Inverse square rule. If you're just a little bit farther away, you get a big drop off in EMF exposure. In the future, in a perfect world, in a utopia, we would be changing this wireless to fiber optic systems. If only we could do that. Do other things to optimize your immune function. And I think that's about it. So I kind of wanted to make the point that there's a lot of potential vicious cycles out there that come from things that increase iNOS. So avoid toxic. Anything that smells bad is usually bad for you. And it often will contain a volatile organic chemical or solvent that can sort of get these cycles going in a bad way. Avoid EMF to the extent you can. Avoid the metabolic problems, the same old low-fat, low-sodium vegan diet. And all these things will help you to be healthier and to not get tipped over into these chronic bad diseases like chronic fatigue syndrome, multiple chemical hypersensitivities, PTSD, tinnitus, etc. So anyways, I thought that was interesting. I think Martin Pall did a fantastic job of putting together all these cycles in a detailed extent, and I thought the whole thing was fascinating.